All right, class. I just want to take a moment to talk about two variable equations, most especially when you're trying to graph. Um, we have the system here. This is what we call the rectangular coordinate system. What it does is that it enables us to plot points and in particular graph, lines or functions, if you want, if you will. Now, the points, basically the points that we graph are what we call the ordered pair, made up of x and y value. So by definition, two numbers associated with a point on a graph is said to be an ordered pair. So for instance, if we take this point here, -4 and 2, this is an ordered pair where the x is -4, y is 2. Okay. Now, the system has been divided into four parts, which mostly we call the quadrants. And we normally name the quadrants counterclockwise. And so we start from quadrant 1, move to quadrant 2, quadrant 3, and quadrant 4. Now, in each of these quadrants, you will realize that the sign of the ordered pair in terms of the x value and the y value, the changes. Okay. There's always a change in them. So like when I move from first quadrant to second quadrant, I will see a change in the sign of the x and the y. So in the first quadrant, all the x and the y values will always be positive. In the second quadrant, the x value is negative, the y value is positive. In the third, we have both being negative. In the fourth, the x value is positive and the y value is going to be negative. Okay, so as a case in point, you see here, the ordered pair is 2 comma -4. The x value is +2, the y value is -4. When we talk about origin, this is where these two lines intersect. At this particular point here, we talk about it as the origin. Here, the ordered pair is such that at that origin is just like a neutral point or a neutral position. If we're talking about taking a real number line, okay, you mostly want to start from 0. Everything else on the right side of 0 will be positive, everything else on the left will be negative. And so when these two lines meet here, this is what we call the origin, where x is 0 and the y is also 0. So the system enables us to, graph points. And then once we are able to get the points correctly, we can join the points to form a line, to form any function in the graph that we want to graph, if you will. Let's go down a little bit. So when we come down here, there's an exercise for us to do. This is very, very easy. Note that the ordered pair has the x value first and the second value is y. And what you have to understand is that the x value is always located on this axis here. So this is the x-axis. That is the y-axis. I think you can see here, y-axis. Okay. So for instance, if I'm taking this here, x is basically x is 3 and y is 2, right? So I'm going to move. This is the origin, right? This is the x. So I move 1, 2, 3. I go this way. 1, 2, 3. This is where I am. And the y is always rising. Okay. So I'm also going to move up twice here. So once I get where the y rises to based on the ending point for the x. That's where I create my point. Okay, so this is that point here. So that would be my point 3, comma 2. If I want to do this one here, -4, -2, x is -4. So I'm going the other way. So 1, 2, 3, 4. And I'm going to come down twice. 1, 2, be where my point is going to be. So that will be the -4, -2. Okay, so you should be able to do that easily. Now this system, like I said, enables us to graph points, join the points, and we can form a graph of an equation, a function, whatever you. We can do this by way of a table. We can do this by way of what we call the x and y intercepts, and then we can do this by y-intercept, again by way of the slope, where we were talking about the rise and the run. Let's go a little bit up. Let me clear this guys here. All right, so in this particular exercise here, it says that in which quadrant or on which axis does each point lie? Remember, we talked about the quadrants. Okay, this is the first quadrant, there's a second quadrant, there's a third quadrant, and that is a fourth quadrant. Okay, so we have this point here. The question is, in which quadrant or on which axis does each point lie? Now, this point is not lying on any of the axes. This is the x-axis, this is the y-axis. It's not lying on any of the lines here. It's actually within. Okay, and so we realize that this point is right inside of the first quadrant. This is in the first quadrant. Okay, now look at this carefully. Remember that we said that any point that you see on the system is coming from an ordered pair, and that ordered pair has the x and the y. Okay, so if you come down to hit the x axis, whatever value you can read there will be the x value, and then you go to your far left to hit the y, whatever y value you hit there. And so this point actually is going to be an ordered pair where my x is 7. This is very tiny, but and my y is 5. Okay, so this is in the first quadrant. This point is in the first quadrant. And when you come to this graph here, look at this point. This point is exactly on the x-axis. It's the x-axis. Point is exactly on the x-axis. Okay, and so because on the x-axis, note that if a point is on any of the axes, one of the values will be 0. Okay, one of the values will be 0. Now in this case, the point is exactly on what? The x. And on what value of x? -6. That tells you that the y value is also going to be 0. So this point that you see here is actually -6, 0. And it's lying exactly on the x-axis. Okay. Let's move down. see. And let me try to clean up a little bit. Now, in this particular case, just from the beginning, we realized that the system, the rectangular coordinate system, or the plane, if you want to call it so, enables us to graph. Mainly, we're going to be, especially in this class, we're going to be graphing lines. So we need to have at least 2 points on the system to be able to graph. Now, in this particular objective, we are graphing a linear equation by using a table. Okay, by a table means that you want to form values. Now, I'm just going to do an example for this one here. I have y equal 3x plus 1, right? I'm going to do a table x and y, and I'm going to assume values. Okay, I'm going to assume value for x and then find the value for y. Basically, if I say x is 0, right, and I put it here, then it's going to be y will be 3 times 0 plus 1. And because 3 times 0 is 0, I add 1 is 1. So when x is 0, my y value is 1. I can also do, okay, x. What about if x is 1? It will be 3 times 1 plus 1. 3 times 1 is 3, plus 1 will be 4. So that will be 1 here for x, and that will be 4 here. You can equally do negatives if you want to. Okay, let's say I do x equal -1. Put it back here. It's going to be y will be 3 -1 plus 1. Now 3 times -1 is -3, and I add 1 to it, it becomes -2. So when my x is -1, my y value is -2. This is what we call the table. Okay, this is what we mean by graphing by using a table. Okay, so now that I have my table, basically the table is just giving me what we call the ordered pair. And so in this particular row, you will see that the x value is 0, y value is 1, and likewise 1, 4, and what, -1, -2. Okay, so I can coolly grab the, let me change that to, let's say, red. I'm going to do the first one. X is 0. This is the x-axis, right? X, and this is the y. First one, I'm looking for this other pair. X is 0, y is 1. Now, x will be 0, only be 0 at the origin, so somewhere here. And I need to move 1 time up. Remember that y always rises up or down, depending on what you have. Okay, if it is positive, it rises up. If it is negative, it goes down. In this case, it's positive. And so my point is going to be somewhere there. Okay. Now I need to graph or locate this point here. X is 1. This x is 1 here. Y is +4, so it's going to rise 4 times or 4 units up from 1. Okay, so 1, 2, 3, 4. That's going to be my next point. And then finally, I have -1. -1 for x. This is -1 here. The y is -2. Okay, so I move down. Okay, y is -2, so I'm going to move down to the negative side of y. is the negative side of x, so -1, and that should be where my point is going to be. So all that you do is you try to get a sharp edge. I mean, if you're doing by hand, to graph, just join the points together. I'm not going to do this perfectly, but probably need to get a sharp edge. But when you put all the points together, just draw a line through and just extend. That will give you your graph. Okay, so this line there is nothing more than y equal 3x. I believe you can do the rest. That shouldn't be a problem at all. Let me try and move down a little bit. Try all of these here, and you should be able to do it. Pause here. Let's try this one here. I'm gonna try and erase everything that we did up there. Now, in this particular case, you are to complete a table, which is basically like what I did before. Okay, over here, it says that 5y minus 4, 5x minus 4y equal 8. And the hint is solve for y first. Solve for y first. Let's see how we do that. Solve for y first. So basically we have 5x minus 4y equal 8. Okay, so if I'm going to solve for this y here, anything that adds to the y or subtracts from the y or divides, whatever you, they all have to go first. Okay, so the first thing that I need to get rid of would be the 5x. It is positive, you don't see anything there. So I'm going to subtract 5x here. I'm going to subtract 5x on the other side because it's an equation. If I do that, I'm going to be left with negative 4y equal negative 5x plus 8. Remember that this 8 there is positive. You don't see any negative there. That's why this plus sign is there, because this is now joining it. And I'm going to divide through by 4, negative 4. The negative 4 multiplies y. So if y is going to be by itself, if I'm going to solve for y, then I need to divide both sides by negative 4. So something like this. This negative 4s will cross out, so I'm going left with my y. Then what is it is that the whole of this is divided by negative 4. I can split them out. So it becomes something like that. Two negatives will always be positive, so that will be 5 over 4x. And then a plus and a negative will always be a negative. 8 divided by 4 will be 2. So this is what the question is asking us. It says, hint, solve for y first. So moving on, this is what we're going to be using. Okay, this equation is what we're going to be using to complete this table here. Okay. Now, in this particular case here, they gave us the x value. They're asking us to use x equals 0. So if x is equal to 0, and I put it here, 5 over 4 times 0 will be 0, and 0 minus 2 will give me minus 2. And the ordered pair I would have formed will be 0, comma, negative 2. What it is that we are going to assume some values for x here. And in all cases, you have to look at your system. Do not use too large numbers. And again, you don't want to also get a lot of decimals. So choose convenient values of x. Plug those back into this equation to see what your y value is going to give you. If I look at it carefully, if I assume that x is 4, right, and I'm plugging back here, then what it means, I'm going to have y equal 5 over 4 times 4, because I assume that this x is 4 here, then minus 2. Now this 4 here will cross out that 4. I'll be left with 5 minus 2, and my y value will be what? 3. So that'll be 3, and I'll form this other pair, 4, 3. Does it make sense? Okay, great. I can also assume another value, which has to be within the system here. Sometimes it takes time to do this, but let's see what else we can do. If I assume that x is, say, 8, right? X is 8. So let me do that. I assume that x is 8. But let me try to clean this part here so you see it more clearly. I don't have enough space, but okay. If I assume that my x is 8, right? That means that if I put it here, right, then my y, based on this equation here, will be 5 over 4 times 8, minus 2. Now, 4 can go here one time. It goes into 8 twice. Basically, I'm left with 5 times 2, which will be 10, minus 2, and that will also be 8. Okay. So if x is 8, my y will also be 8, and that will form the ordered pair 8, 8. Once I form this ordered pair, I should be able to graph. Now, in the first ordered pair, x is 8, which is here, and then the y value is also positive, so I move up. So I'm going to locate my point here. Second one, the ordered pair, I have 0, -2. X is 0. X can only be 0 at the origin. And then y is -2, so it goes down here. And finally, I have x4, which is this one here. And then the y value is positive, so I'm going to move up 3 units to there. You get your 3 points. At least you can get 2 points, at least 2 points to graph. Again, I know I can't get this too smooth. I'm just using my hands. I'm just going to join this to that, join this to that, and extend it further here, extend it further here, and that gives you a line. Okay, so I know you can do this easily. Let's move down, see what we have there. These are our exercises you can do. Okay. erase everything else here so we can see what the next thing is. Now, in this particular objective, we're talking about graphing linear equation using the x and y intercepts. The x and y intercepts. And this is what has been designed here for you. This is the x here. This is the y here. Okay. So when we're talking about the x and y intercept, anytime you graph a line or you have a line that crosses the x and of course the y, we do have an intersection. Okay, and that point there is what we call the intercepts. Now, the x-intercept is such that you cross the x-axis at a particular point, okay, but your y value will be 0. Again, for the y-intercept, you also cross the y-axis at some y value, and your corresponding x value is 0. That is what the intercept is all about. So it says the x-intercept is the point at which the line crosses what? Crosses the x-axis. Okay, crosses the x-axis. Okay, to find the x-intercept. Okay, now because we are talking about the x-intercept, we need to get a value on what? The x-axis, but the y value is always going to be 0. So we set y to be 0, and then we solve for x. Okay, and because y is 0 and we're looking for some x value, it is written in the form. Okay, a form where we're looking for the form is always a point. Okay, so basically it's just going to be something like that, the x value and then the y value is 0. So this is the point, the x-intercept. And when we come to the y-intercept, is the same preamble here. The y-intercept is a point at which the y crosses what? Is a point at which the line crosses what? The y-axis. Okay, so the y-axis. To find the y-axis, same idea. If you are on the y-axis, you have a particular y value, but your x value is always 0. So we set the x value to 0, and then we solve for y. Right? For that reason, the point, or basically the y-intercept, is always going to be a point. You can write it as x is 0, so x is 0, and whatever the y value is. In this particular example here, we have to graph 5x plus 10y equal 10, right? And we have to use the x and y intercepts. So x-intercept, your y is always 0, and you are exactly on the x. The y value is 0. So if my y value is 0, I plug that in here. It's going to be 5x plus 10, 0 equals 10. Everything now here is going to be 0. So 5x will be equal to 10. And dividing through by 5 gives me x equal 2. Okay, so my x-intercept is actually what? 2, 0. Does it make sense? If I need my y-intercept, is the same thing. Y-intercept. If I'm on the y, my x is 0. Okay, so again, I'm going to put it here. I have my 5x plus 10y 10. So if my x is 0, I put it here. It's going to be 5 times 0 plus 10y equal 10. 5 times 0 is 0. 0 plus 10y is the same as 10y. That should be equal to 10. And I divide both sides by 10 to get my y by itself. and that should give me 1. That tells me that my y-intercept is nothing more than 0, 1. And this is what I need to locate. I need to locate this point, and to locate that point, join these two here and form my line. So if I'm going to start with the first one, my x is 0, my x is 2, sorry, and my y is 0. So the point will always be on this, okay? Anytime you have an ordered pair, one of them is 0, the point always goes on the non-zero pair, if you will. So again, if I'm doing 0 and positive 1, x is 0, y is 1. So it has to be here. So I get these 2 points. Remember that to get a graph, at least 2 points suffice. Okay. So you don't need to get a third one. You can get a third one if you want to, but 2 points are good to go. Just joining these two here. I'm not drawing perfectly, but do that and extend that. You get your line. Okay. That's how we do the slope intercept form. So you can try the rest. They're not too hard. Let's look at this objective here. So try and get rid of that so we can have space. Okay, so now in this particular objective, we're talking about graphing linear equation using the y-intercept and the slope, the y-intercept and the slope. Now we have what we call the slope intercept form. The slope intercept form of any equation is y equal mx plus b, and it has the m there is always the slope, m as a slope, and the b there is what we call the y-intercept. Mostly the y-intercept is always a point. Okay, so if anything, if you are writing your y-intercept, it has to be a point, and so the x value is going to be 0, and then the y value is this b here. So that will be your intercept. An example says find the slope and the y-intercept of this line. Okay, this equation is given in what we call the standard form. This is in standard. This is in standard form. So for us to get the slope and the y-intercept, we have to put it into this form here. Okay, so I have 3x minus 6y equal 12. What it means that I need to solve for y. Y has to be by itself. Now, if I look at these numbers, these coefficients, this is 3, this is 6, this is 12. I see something in common. 3 can go into each of these numbers. So I can decide to divide here by 3, here by 3, and here by 3. If I do that, it's going to give me x. That gives me 2y. And that gives me 4. Okay. So divide by 3. If I divide by 3, this is what I get. Then from here, I'm going to try to solve for for y. Right? So what I can do would be to move places. Okay, I can move the 4 here and then move the 2y there. Okay, if I move the 4 over, because it's positive, it comes over to be negative. I'm also going to move the 2y to the other side because it's negative, it goes there to be positive. Then finally, I'm going to divide both sides by 2. Okay, in other words, I divide every term here by 2. So x 2, 4, 2, 2y 2, that'll give me y 2 minus, that will be 1/2 x. Basically, that's if I push the x a little bit to the right, there's always a value in front of the x here, which is 1. It's hidden. So if I try to push it a little bit away, that will be left with 1 there. Okay, so this is what I have, and it's exactly in what the y equal mx plus b form. So that tells me then that my slope is always the value in front of x, just like we see here. So the slope is 1/2. Y-intercept is, remember the y-intercept is of this form. It's going to be 0, and whatever the b value is. The b value in this case is what? -2. Okay. It's the same idea here. Let me just get rid of this now that you know. So let me get rid of that and do the b parts for you. I mean the exercise 5 as well. Okay. Now in this particular case, I can divide any of this by any number. Okay, it's nothing common. Okay, so all I'm going to do is my -3x plus 5y equal -15. I'm going to solve for y. This -3 has to move away because it's negative. I'm going to add 3x to both sides. If I do that, I'm going to be left with 5y equal 3x minus 15. And then I divide each of these here by 5, just so that the y will be by itself. If I do that, I'm going to have something like that. (15) divided by 5 will be 3. And I'm all set. It's in the slope-intercept form. That tells me that the value in front of x is going to be my slope, and this -3 forms the y-intercept. So the slope m is going to be 3/5. The y-intercept, remember, is an ordered pair, is a point. In all cases, y-intercept has to start with a 0, and then whatever this value is should be all set. All right, let's move down. Let's clear just to have space to look at the subjective here. All right, so we want to look at how we can graph a linear equation using the y-intercept and the slope. Remember, we've talked about getting the y-intercept and the slope from slope-intercept form. So first off, by the steps, you need to plot the y-intercept, and then from the y-intercept, you're going to do the rise and the run, depending on whatever you have. Remember that if the y value is positive, it rises. If it is negative, it rises down, or rises but it goes down, or moves down. If it is positive, it moves up. Same with the x value. If the x value is negative, you're going to go to the left of 0. If it is positive, you go to the right of 0. Okay, so you should know some of these things. From the y-intercept, rise and run however many units which the slope indicates. So if you're going to have a positive slope, then basically both the rise and the run values will be positive, or both will be negative, basically. In a negative way, one of them is going to be negative, mostly. So if I'm looking at y equal 5/3x minus 2, right? I know that based on y equal mx plus b, my slope m is 5/3, and my y-intercept is 0, -2. Now, plot the y-intercept first. This is the y-intercept. It is 0, 2. I mean 0, -2. So 0 is here, -2 is here. So this is my y-intercept. Then I know the slope is rise over run. Slope is 5/3, which is rise over run. The 5 is positive, so I have to rise 5 units up because it's positive, right? 5 units up from what? My y-intercept. So I'm going to have 1, 2, 3, 4, 5. So basically, this is where I am. And then I'm going to run 3 units because it's positive. I'm running to what? The right side. So I move 1, 2, 3, 4, 5, and I run 1, 2, 3. That gives me another point. So let me go over again. First off, you need to be able to determine what your y-intercept is. And from this particular example here, y-intercept is what? 0, and this number here, which is -2. So we locate that first. 0, 2. This is -2. This is where my point is. Based on my point, I have to look at the slope. Rise over run. You either rise up or you go down. If it is positive, if the number for rise is positive, you move up. If the number for rise is negative, you go down. So basically, we're talking about it going up and down on what? The y-axis. Now, in this particular case, it's positive. So I'm going to be on my y-intercept. I'm going to move up or rise up, rise 5 units. 1, 2, 3, 4, 5. Do not put a point there. This is just like an imaginary point. Okay, so in your mind, this is where you are. Now come and take into consideration what the run is. Run is 3, positive. It means you are running to your right side. So you move up to here, then you run 1, 2, 3, and you form another point. All that you need to do, join these 2 points, extend, and you are all set. It gives you a line. So you can do this. It's not too much of a big deal. Do the rest. Let's talk about this objective here. Let me try and clean up a little bit. Now in this objective, we're talking about graphing horizontal and vertical lines. Horizontal and vertical lines. By now, I believe you should know what a horizontal line is. A vertical line is. Okay. We talked about the system. There's a system that we're talking about. This is Y, this is X. This line is horizontal. This line here is vertical. Basically, any line that goes through the x-axis is always a vertical line. A line that goes through the y-axis is always a horizontal line. So it says for horizontal line, the equation of a horizontal line is in the form a horizontal line. Okay, any line that goes through the y, okay, is always a horizontal line. Any line that goes through the y, okay, so definitely a horizontal line has to pass through a particular y value. So let's put it this way: y equal a, and it says where a is a number. Okay, so let's say that if I draw one line here, it's a horizontal line, right? Let's say it goes through this value a, right? This is that line. It's a horizontal line. And then a vertical line is a line that goes through the x. So if I draw this line through here, and let's say it touches at this point here, A, then this is a vertical line that goes through this x value here. So the equation of the vertical line is in the form x equal A, where A is any number. See what we have. Based on the explanation so far, we can graph the following, because any line that goes through the y means a horizontal. Okay, y is equal to 6. So you just want to locate 6. This is 6 here. So the line that goes through 6 is going to be this graph. This graph here is going to be y equal 6. Okay, if you look at this, it's x. X equal -3 is somewhere here. So this line is going to be that line that you're looking for. Okay, it's not anything so big. Okay, that is how to graph this. Okay, we're going to move on to go down. You can do this. Some of these things are very easy. But so that is what we have. Should be able to do some of these things, and I hope this video helps you out.